my name is Wei. I'm the tech evangelist of Samsung ARTIK IoT platform. I have been working for Samsung for a couple of years. Before joining the IoT team, I was the tech evangelist of Samsung Mobile, Samsung wearable devices, and briefly on VR. So today I want to leverage my experience on IoT and webVR to talk about how these two technologies can converge with each other and how web developers can adapt their existing skill set to do IoT development. So Samsung IoT, okay, still booting. So we manufacture, so let's first talk about what Samsung IoT offers. So we're trying to provide a from module to cloud experience. If you are new to IoT, IoT module is basically the brain of your IoT devices. So think about your Amazon Alexa, your smart door lock, or even your smart coffee machine. Each of these devices are being powered by an IoT module inside it. So it has certain kind of CPU, a fixed amount of flash or RAM, or provide different I/O connectivities to support different peripherals. So because IoT use cases are so diversified, Samsung is leveraging its manufacturing power in semiconductor to provide a family of IoT modules. So in the lower end, we have what we call ARTIK 0 module. So ARTIK 0 module is to be used in battery-powered, lower power consumption devices. For example, your light switch or some small smart home appliances. So the module on the left side is what I just talked about, ARTIK 0 series. So in the middle, we have what we call ARTIK 5 and 7 series. Those are to be used in IoT gateways or hubs. So you can use this kind of module to do data aggregation, data filtering before sending the data to the cloud side. Or you can run your edge analytics algorithm or even machine learning algorithm on top of this. We have some demos displayed on the tables outside, so feel free to stop by once the session is over. So on the right side, we also provide ARTIK Cloud service. We just rebranded to be SmartThings Cloud. And one of the biggest challenges when running into in developing IoT solutions is interoperability. Think about this. Your IoT devices are provided by different vendors. They come in totally different form factors. They probably support different radio connectivities like Wi-Fi, Ethernet, Zigbee, Bluetooth, Thread, and they're running different kind of operating system. On the higher-end device, it's probably a Linux variant. On the lower-end device, it may be bare metal or a real-time operating system. They run different software stacks. They use different communication protocols at the software layer. So how can you let these different IoT devices to talk to each other? So that's why we are trying to utilize capabilities provided in ARTIK Cloud service to bridge different kind of devices together and provide IoT interoperability. So this is from module to cloud experience. We're still missing one big piece here. Can anyone guess what it is? Security. So as a developer myself, security has always been the thing that I want to worry about later. I'm not sure if you saw the forecast online that by year 2020, the number of IoT devices will be connected IoT devices available. I think the latest forecast is about 30 billion devices. So if we have those many of connected devices, security has to be the thing we worry about now. So when you think about security, think about these questions. How can you protect the communication between your IoT devices or between your IoT device and the cloud? How can you establish the identity of each individual IoT device? Are you going to use keys and certificates? How can you guarantee your keys and certificates are unique throughout all these devices? And how can you protect your unique keys and certificates? If you are trying to inject your keys and certificates to your IoT modules during your manufacture stage, do you have the infrastructure to support that? So for all these questions, Samsung ARTIK provides different approaches to help you address them. So although we're trying to provide end-to-end integration, bring you from module to cloud experience, at the same time, we're trying to keep our platform open. So even if you choose to use ARTIK module, you can still leverage different cloud services out there. We support AWS, Microsoft Azure, PTC ThingWorx. All the popular cloud services are compatible with ARTIK platforms. Or we are open on the front end as well. So if you choose to use SmartThings Cloud as your backend engine, you can use different IoT modules to connect to it. IoT is very complicated, so no companies can do it alone. That's why we're leveraging our strong ecosystem, our partners, to provide solutions at different layers. So dive a little bit deeper into the module side. So this is our line of products. For ARTIK 0 modules, we have ARTIK 020, which is a Bluetooth low energy device. 030 supports Zigbee and Thread. And the 050 series is our Wi-Fi product line. So all these devices are powered by single or dual-core Cortex-M or Cortex-R CPUs. They're running bare metal or real-time operating system on top of that. Of course, we provide internal RAM, flash, and secure subsystem to support our security features. On the right side is our high-end gateway modules, ARTIK 5 and ARTIK 7. They're using quad or octa-core Cortex-A CPUs. Being powered by Linux-based platforms, we're supporting Ubuntu in this as a default operating system. Of course, hardware secure element is included. And on top of that, we provide software solutions like Edge Node Manager to help you connect non-IP-based devices like Bluetooth low energy device or Thread devices to the internet. We also provide mobile applications to help you manage different nodes in your IoT networks. So some of these orange products here, as you probably have noticed, all of them has the ending of S. So these are the new models we just rolled out last November. They're secure modules. We provide enhanced security by using different security measurements have been included in the security modules, and we provided these additional features to developers with no additional charge. On top of the existing hardware infrastructure and software solutions, our wireless functionalities and protocols are also pre-certified in different regions of the world. So as an OEM or developers yourself, once you build a product on top of ARTIK modules, you don't have to go through the lengthy and complicated verification process yourself. We have pre-integrated, fully tested OS and middleware to make your development work easy, and also integrated hardware and software security features. On the cloud side, as I mentioned earlier, one of the biggest challenges we run into is interoperability. And we use mechanisms like data normalization and cloud connectors to help you bridge different IoT devices together. Data normalization is we provide a JSON format manifest file to associate your physical device. So once your device talks to ARTIK Cloud, all the communication format is based on JSON. That's why devices from different vendors or talking about different protocols will be able to communicate with each other by using the common language in the backend. Cloud Connector is something we have been building internally, and we also get a lot of support from our developer community. For example, you probably want to let your alarm clock to talk to your coffee machine. So your coffee machine knows when it's time to brew a cup of coffee for you. So in this scenario, two different private cloud services needs to talk to each other in order to, figure out when the thing will happen. And in order to do that, by using the building cloud connectors, we bridge these different private cloud services together, and consumers can simply plug and play to connect these pieces together. We also provide device management capabilities in the backend. If you deploy your IoT modules to thousands of smart trash cans out there, you probably don't want to physically visit each of the trash can to update the firmware. So we rely on our OTA solutions in the backend to do the over-the-air update. We also have an orchestration engine, or what we call rules engine, in the backend. So you can define certain rules. Again, use smart trash can as an example. When your trash can is getting full, you probably want to call somebody to pick up the trash. Of course, security and privacy management is our top priority for ARTIK Cloud Service. So we talked about some of the security concerns when we first started. These are the different mechanisms we have in the picture to address different security issues. So each ARTIK module is pre-injected with a unique key and its associated certificate during manufacture stage, which helps the IoT module to establish the identity when it's get onto the public cloud. On the SmartThings Cloud side, all ARTIK modules have been whitelisted. So if your module wants to talk to SmartThings Cloud in the backend, they exchange keys. They will be able to verify each other to establish a mutual authentication channel between them. We have our own public key infrastructure. So we manage the keys on each modules as well as on SmartThings Cloud domains ourselves. So this is a very unique feature. No other competitors provide that. On our modules, we provide secure storage. So secure key storage or secure element to help you protect your device-specific keys and certificates. On the higher-end module, like 5 and 7, we leverage ARM's architecture to provide secure OS. So basically, there is a physical division on your ARM processor to divide it into what we call a normal world and a security world. This technology is not only being utilized in IoT devices, it's being utilized on your mobile phones as well, like your Samsung smartphone. Content like your fingerprint is actually being saved in the secure world to make sure it's not being tampered. We support secure boot. So when you boot up your IoT device, before executing the software piece is being verified. And all the communication between module and cloud and between your mobile device and the cloud are encrypted, and we have to use OAuth authentication. So some use cases to help you understand what we can do here. So Samsung has been teaming up with Marriott International and Legrand, who is a global vendor of digital building infrastructure, to bring IoT into Marriott's hotel rooms. So some of the challenges Marriott runs into when they first built this is they already have different products in their hotel room. And how can they let different product lines to communicate each other? And how can they roll out the solutions to the market fast and provide interoperability between all these different devices. So eventually they choose to use ARTIK 0 series as in their smart lighting, smart environment sensor, and also use the ARTIK higher-end modules as the gateway device for hotel rooms. In the backend, they're leveraging ARTIK Cloud Service for interoperability. So all these devices from different vendors will be able to talk to each other. So the reason they chose ARTIK, because we are Wi-Fi certified in different regions, which reduce their product development time and their time to market, security features, and also interoperability provided at cloud level. This is another example here, one of our NDA customer who is a wholesaler of insurance. The challenge they ran into in their daily use cases is they want to reduce risk and associated cost, how to improve access to their customer data. So eventually they choose ARTIK Cloud Service and ARTIK 7 as their gateway solution. So they have ARTIK 7 deployed in different locations to provide remote access to on-site data in real time. Also, they leverage ARTIK Cloud to provide interoperability between multiple sources. So some of the use cases to help you understand ARTIK's story. So moving on to the VR part, especially webVR. I know some of you are probably web developers. Believe it or not, you already possess a lot of the skills to develop for IoT. Take JavaScript as an example. On our low-end modules, we're working on to port JavaScript, which is a JavaScript engine designed for low-footprint devices, to our real-time operating system. On the higher-end modules, because it's already Linux-based, we already have Node.js pre-installed for you. So you can simply develop JavaScript for all line of modules. Also, there are development tools like Node-RED. I'm not sure how many of you have tried Node-RED. Anybody? Yes, huh? Yeah, it's basically a Node.js-based tool. It's flow-based, where you can use drag and drop to design your own program flow. And all the program you created can be converted to JavaScript for the Node.js to interpret. I will show this in a demo really quick. And in the backend, we're using the same databases, same cloud services from MongoDB, Redis, or SQL-based database to the cloud service like AWS, Microsoft Azure. So those skills can be easily adapted to IoT development. And the other feature we're leveraging a lot is web service integration. Like what we mentioned, use cases we mentioned. For example, if you observe some of the sensors is behaving abnormally on your factory floor, you probably want to create a Zendesk support ticket. Or if you monitor your trash can is full, you probably want to use Twilio to call somebody. So all these web services integration can be translated to REST API or SOAP API, which web developers are already very familiar with. And the other aspect that web developer can really shine is rich and complex UI development. So most of the IoT developers are from embedded background. We don't really know how to design a beautiful UI. But web developers already has the knowledge and awareness of all the modern frameworks to build, rich UI experience on top of your IoT products. So we worked with Samsung Internet team and built a proof of concept last year. So as you can see here, we actually have a Lego tower bridge. And we embedded different sensors onto the bridge. For example, we have a sensor hooked up to the bottom of the drawbridge in order to detect if the drawbridge is open or closed. We have a pressure sensor here on the bridge to detect the weight of passing vehicles. There are also like a traffic counter, temperature sensor embedded at the different locations of this bridge. And we call each of these sensors are hotspots. So in order to bring the experience to the next level, we work with Samsung Internet team to add webVR components to it. So on the right side, you can see this is our webVR view. So basically, once you put on the goggle or open your browser with that particular web page, you will be able to see a 3D model of the Tower Bridge. And at each of the hotspot locations, you can get the real-time sensor reading from those sensors. So this is a really cool demo, and we got a lot of interest from city management. So they will be able to visualize, you visualize this from their own infrastructures. So webVR and IoT are being heavily used in other industrials, like robotic assistant surgeries. So one of the areas is people use webVR and IoT to train surgeons, to help surgeons build up their muscle memory. Not only surgeons, but also athletes, or even in military trainings. These two technologies have been combined together to bring you the training experience. IoT city management, like the Tower Bridge use case we just talked about, telepresence. So these are some of the use cases. So before ramping up here, I have a demo which I put together yesterday. I spent a couple of hours on this. So this demo is actually running on an ARTIK 5 module. This is the board developed by one of our partners. You can see the form factor of the board is fairly small. But on top of the IoT module, they also embedded different sensors like accelerometer, gyroscope, temperature sensor, humidity sensor, and even connectors to external displays, GPIOs. So by using this board, I'm trying to leverage the different sensors on top of that to simulate, tilt. Here, let me connect to it. Yeah, because my device is headless, and I don't really have an open network here. I have to use my mobile phone as the hotspot. Make sure I'm logged. So I will start the Node-RED 2. So I actually have Node-RED pre-installed on the IoT module already. So now, if you host a machine and your IoT module connects to the same Wi-Fi network from your host machine, which is my Mac here, you will be able to access your board from its IP address. So this inclination angle is basically, I'm using the accelerometer on the board to check if it's in a flat position or not. I got this concept from a Hackster article. So let me try to launch something else. So this is a web VR program based on A-frame. So once I open it up, you should be able to see snowman, 3D snowman from the web browser. So the concept of this is actually you embed this to at the bottom of a snow globe. So once you turn it upside down, you should be able to see more snow coming down on the snowman. So here, this is the Node-RED 2 I just introduced. Again, it's based on Node.js, and you can simply use drag and drop to design your program flow. So here, I'm trying to calculate the tilt angle by using the accelerometer data I collected from the board. And based on the different tilt angle, I want to see less snow, a little bit more snow, or I want to see a rain. So that's the basic logic behind this. So now, not too much snow. I will turn this upside down. There's a little bit latency here, but now you can see more snow coming down. So this is how you can leverage IoT and a webVR experience. Yeah. Cool. Thank you. Yeah, any questions? I will be here in the afternoon. Feel free to grab me if you have any questions. Yeah, thank you.